We'll get started, and I'd like to start off by welcoming you all here and welcoming our presenters today. I'll be introducing them shortly. And I'd like to start off with this slide. This slide that shows how to keep up with the rate of EV adoption, we need tremendous growth in EV charging infrastructure, double-digit growth year over year, both in the US and Europe. Now, it remains to be seen how the new administration in the US will affect this growth over there. But there are still state and local initiatives supporting infrastructure rollout, as well as investments from the private sector. And we may find that the market forces of EV adoption will continue to drive growth in infrastructure, even with reduced federal funding. Now, the problem is that utilities can't keep up with the growth in EV adoption. And the ensuing growth in infrastructure strains the grids. Demand for EV charging is growing much faster than the rate at which they can upgrade the grid to provide the demand for energy. Now, these articles show that grid constraints are a real thing, and it's happening today. But I'd like to start by showing you some data. This is data from Drive's platform showing that network operators, that's our customers, are really beginning to understand how smart charging can help relieve grid constraints. We've been seeing 500% growth in the number of smart charging transactions over the last 2 years. And that growth, it's not only in absolute number, but also in terms of the percent of total transactions. So smart charging is becoming the norm for charging networks. And Oren and Yossi will soon show you what we mean by that. But I'm going to stop here because I don't want to steal the show. And I'd like to introduce you to our lineup today. So we do have a great lineup for you. Now, the Netherlands is a front runner in EV adoption. But that high level of adoption is also contributing to the challenges the country is facing with congestion and capacity. And we have a long history with ELAD, and we're delighted to host Arjan here today. Arjan's going to highlight some of those challenges and show how grid operators are using the flexibility of EV charging to overcome them. Then our own Oren and Yossi are going to tag team to show you a variety of means that network operators have through the smart energy management capabilities of our EV charging platform to address constraints in grid capacity, and even how some of those capabilities can generate revenue. And I'll be here in the background. Yep, that's me. I'll be here in the background working the mechanics of today's events. And just before we get started, a little bit of housekeeping. Your mics and cameras are off, but we'll be happy to get your reactions during the presentations. There should be time for questions in the Q&A section, both at the end of each person's talk and at the end of the webinar itself. And finally, we will be popping up some questions for you to answer during the webinar, so stay sharp. And with that, I'm happy to hand over to you, Arjan.
Great, thanks, Rami.
Take it away. I'm going to stop my share, and you can grab the share from me.
All right, then I will try to do this.
Super, we can see that.
Yeah, okay, great. So thanks for the opportunity to tell you a little bit about the developments in the Netherlands. So we are a front runner of e-mobility, but we are unfortunately also a front runner in terms of grid bottlenecks. So a front runner is not always a good thing. I am with ELAD. I will tell you in a bit something more about ELAD, and I will sketch a little bit about the context we're living in, grid-wise, so to speak. Top shortly balancing and congestion, which are two different things, but both ask for flexibility and as such integration. And I split a little bit between medium and high voltage, one part, and the developments on low voltage level is as the other part. So a little bit about ELAD first. ELAD started in 2009 already, so we are like 15 years old, so to speak, and we are a distribution system operator, grid operator foundation. And we were founded by the mutual Dutch DSO's to foster electromobility by installing a nationwide covering network of charge infrastructure, and at the same time collect data to assess the impact of e-mobility. And we went to a few few phases, few strategic changes, and also a few changing operational goals. And we are now at the phase that we try to not only try, but we do actually help to integrate electromobility in our grids by improving interoperability. And interoperability goes back to the starting years of ELAT in 2009, where we initiated and co-developed with RISE and others, for example, the OCP protocol. So that interoperability aspect remains within the ELAT goals, the ELAT organization. Balancing and congestion, very shortly then, because most of you know what it is. Balancing is about the balance between consumption and production. Should always be in balance, and with the sustainable sources coming in, it is harder and harder to adapt production. And now we are looking at demand side flexibility, so to means to adapt demand to supply. And congestion is about the thickness of the cable, so to speak. And can we transport all the production from one side to another, or can we transport all the needed consumption capacity from one point to another point? Both are important, and people are active in it, but I will focus on congestion today. Development of congestion since 2020 until now, it kind of surprised at how fast it went. So that's the main thing with this sheet. You see quite a smooth growth of the not so good red corners. Production congestion was a little bit earlier than consumption congestion, but also when congestion on production side was there, we estimated that consumption congestion that was about in 2021 would not become such a problem. But in 2024, we know that it's different. On every grid level, the challenge of congestion is there, or grid bottlenecks is there. Congestion is a formal state of the grid on medium voltage and not yet on low voltage, but also on low voltage we have bottlenecks. What is now happening, increasing on this medium voltage level, that is in terms of e-mobility, the electrification of logistics. You see here a picture that it is now in development, but we are far from there yet. Actually, we're just at the beginning of the situation, and we have to install e-mobility for trucks, charging infrastructure for trucks in the already congested grids. And what are we now going to do about this in the Netherlands? I will discuss two aspects. What is for these high grid levels? That's on one hand, new grid contracts, and the aspect of these new grid contracts is that the consumer, mostly commercial or industrial consumer, has now the choice for new grid contracts, which are cheaper but do not always offer the same amount of capacity. So during certain times of the day, the amount of capacity, the available capacity, decreases. And then that's the first three contracts. And then it is up to the consumer to keep within the capacity boundaries which are changing. And the line of thinking is that these variable capacity contracts are going to be more dynamic over time, when also grid measurements are and grid systems are more mature. Bottom line is that these companies are responsible by themselves to keep their capacity demand within these boundaries. The last one, special one, group transport agreement. It is also now possible in the Netherlands to have a group transport agreement, a group of companies in one area behind one substation can contract together an amount of capacity, and together they have to keep within the limit. So the assets within this group of different owners should behave in a certain way that they can keep within the grid contract. And also this agreement will be more and more variable and dynamic in the future. The bottom line is how more flexible you can be, the cheaper the grid contract, but also the sooner you can have a bit of capacity you ask for, because congestion means that there is no room, should have told you that earlier, for a customer with a traditional contract. Another way is congestion management. So through a platform like GoPax, that's the Dutch platform, or through bilateral contracts between a DSO and a connected party, the DSO can buy back as such capacity flexibility. And for this, there is a standard interface defined. And this, both of these aspects, and there are some more, ask for integration on site between chargers, but also other assets like a battery, for example. What is now happening on low voltage in the streets, where most of the EVs park in the Netherlands? Also, you see here an adoption scenario that we are more or less at the beginning. So electrification of mobility will continue, and we need more and more different kind of chargers: home chargers, public chargers, and workplace chargers. And these chargers are not evenly spread throughout the Netherlands. So you see a lot of home chargers in the more rural areas of the Netherlands, and you see a need for more public chargers in the more urban areas in the Netherlands. And you see also that the need for chargers, they correlate with the most congested grid situation in the Netherlands, more or less. And what is now the solution to manage these needs for charging infrastructure in the street in these areas, which will probably to have grid bottlenecks in a few years? That is what we have called grid-aware charging. What is that? That is a way of it's just normal charging, plugging in, but there is an agreement behind it between the DSO and the charge point operator that in areas where they're facing grid bottlenecks, the capacity, look at the first graph, is decreased during certain hours of the day, mostly at the evening times, not always to zero, almost not to zero, but to a basic available capacity, and during the night the capacity increases. And this is now something which is in development, and also where ELAT has played a part and is playing a part. First, we're now in a phase that we are agreeing to a static profile, and via the grantor, this is part of the agreement for the charge point operator to install charge points. In the second phase, we are now in this year, next year, we want to make a interface between the DSOs and the charge point operators to be able to send this profile through an internet interface. We chose Open ADR for that, to be specific. And in the last phase, so more or less the end phase, we want to make this profile based on grid measurements. So grid measurements, calculation of the available capacity, and that communicated from the DSO to the CPO in these areas where there is a bottleneck. And this is an agreement in the contracts of the grantor but this should also be incorporated in a capacity limiting contract specifically for charge points. We're running a little bit out of time, but this is, at least from my perspective, the most interesting part, grid-aware charging at home. This can be possible, this is possible when this charger is connected to a CPO or connected to another system. But when we look at grid-aware charging at home, there are also interest of more efficient use of heat pumps, more efficient use of home batteries, more, not per se curtailing, but more efficient use of PV production at home. So we are now looking, investigating, and developing in pilots architecture which resembles a little bit like this sketch. We are an aggregator, or where the DSO can communicate with different aggregators, which can communicate with different home energy management systems, and behind that, the different in-home devices. This is going to be a roadmap. This will not be there all of a sudden, but this is something we work on with our DSO branch organization, with our Ministry of Economics, to see what we can do to make this happen. There are different pros for this approach in relation to the silo approach to just connect one specific device. Questions about this, Rami? Is that now the time or later? You're muted, I think. Rami, I think you're muted.
Still mute.
There we go. That'll always happen.
Yeah.
So yes, of course, we have some questions. Your slide about the new grid contracts have raised some interest, but before those, someone's asking about the percentage ratio of fast chargers in the Netherlands and how quickly is that growing? Is it growing rapidly?
Percentage, I have to look that up, but percentage of fast chargers in relation to DC chargers in relation to AC chargers, it's 1-2%, and it stays more or less that way. But I have to say that the installed base of fast chargers is already quite okay. We have the AFIR, the Alternative Fuels Infrastructure Regulation in Europe, but these are not putting extra demands towards the Netherlands because we are already set regarding fast charging points along the highway. But it's, I would say, 1-2%. I can look it up and send it on later.
Mm-hmm. Okay, super. Let's go on to the next question. Someone's asked about how does grid-aware charging work? Is it by monitoring price or by monitoring voltage levels?
No, it is by monitoring the capacity of the grid, and when the transformer is up to 80% of its capacity, then there is a profile of available capacity agreed upon between the DSO and the CPO, and the CPO activates this profile of available capacity over a number of charges. So the charges together in that area cannot go over this agreed upon capacity. So it is capacity management, which is actually on request by the DSO, but executed by the CPO through OCPP to the chargers.
Maybe, Rami, maybe I can add to that answer. You can say that there is a passive way and an active way. The network can set up dynamic prices, and by that, hoping that the consumers will act and reduce charge when energy is more expensive. This is like the passive way to do it, which can be done. A more advanced way and a more effective way is the active way, where the network actually instruct or request the CPO in this case to reduce charging or reduce congestion, both can work. The second one is more active, but it's more advanced.
We're actually going into that in the next slides later on.
Okay, let's go on to one more question. I think we have time for that. So someone's asking if the new grid contracts are ongoing valid contracts, and are they only for home charging, or do they also include logistics hubs and truck charging?
Yeah, I check. Very good question. These contracts, they are especially meant for connections on a high grid level. So they are more specifically made for logistic hubs or logistic companies for depot charging, or for other industrial commercial connections on high grid level, and not yet for the low voltage for the regular consumers. They are not yet for the houses ready. For the houses, for low voltage, for consumers, we are thinking a little bit different than these contracts for the connections for the industrial consumers.
Okay, and we'll take one more now to make sure that we have enough time for Yossi and Oren. If there's time at the end, maybe we'll take more. I'll take this one. Someone's asking what roles utilities and operators of EV charging infrastructure can play with respect to power management, and what business models are applicable.
Yeah, so power management, that I would translate that to capacity management. For congestion and for balancing, the roles are quite, or the possibilities are quite broad. So the DSO, but also the TSO and also the balance responsible party can all request flexibility in ramping up or ramping down. I showed you two examples from a DSO perspective where you have specific variable contracts where it is like you can also do that with pricing, so that's implicit demand response. In grid that we are charging, explicit demand response, active demand response, as Oren described it. Those two roles are there. The second role, explicit demand response, you can fulfill that in an market approach. So the DSO pays or provides a discount to provide this ramping up, ramping down in terms of flexibility, or it can be part of regulation, so like we have in Germany on a low voltage level. So there are numerous of possibilities and as such business models or models to be worked out. And I think the contracts I showed and the grid we are charging, that are the first versions of the possibilities we will get in the Netherlands. What's also very interesting, but it's for the longer term, that's like the energy hub, shared energy management, shared capacity management over a campus. So there are numerous possibilities in that aspect.
Okay, I think we'll have to end it here. We're still getting a lot of questions in, both in the chat panel and in the Q&A panel. People are asking about that, but I think we've run out of time for now for your part, Arjen. So I'd like to thank you very much for joining us today. Please do stick around, because if we have time for some more questions at the end, we may turn to you again. And I think this is the time now to take you off screen, and I'm going to bring Oren onto screen. There you are, Oren. Good to see you here, and go ahead, take it away.
All right, and I hope you can hear me well and see my screen.
Yep, we do.
Excellent. So really exciting to join this webinar, and thank you, Rami, for this really great opportunity for us to present. And it's a really nice transition from Arjen's presentation, because I think Arjen showed what is the problem, and where does the market grow, and where we're going to end up without smart energy management. And that's what our presentation, Yossi and mine, will focus on today. All right, great. So smart energy management enables the network operators, which we just saw in the survey that it is some of you guys, to optimize how all the energy sources at a site are used to accommodate EV charging. These sources could be the actual grid, which Arian is responsible for and described. It could be renewable energies such as PVs. And in addition to that, it could also be batteries. So if we take all those three inputs and we see what is the best input to use, when to use each one, and how to combine them, that allows us, or you as a CPO, as the one who operates the site, to look at the EV load in addition to the unmanaged load, and see how the varying cost of energy that's coming from the grid works together with the batteries and PVs. That works in order to, first of all, improve the energy resiliency of the EV charging sites, so you have enough energy to charge at all time, while increasing the ROI of EV charging infrastructure, and I will talk about this in the next slides. This goes, of course, very well in a single site where you need to balance your car cleaning, car wash together with your charger. But that also works well when you look at multiple sites, what we call a campus, or a city or a whole country. And this is where the DSO, TSOs, and the balance responsible company is taking effect when they ask the CPO to reduce charging. So when we look at a site, typical site, what do we see? Multiple chargers. Those could be a combination of ACs and DCs. It could serve local, it could the employees, people who lives there, their home, or it could be a public charger site that serves trucks, buses, or private cars. Together in the same site, we see in many cases additional inputs. As we said, it could have a battery that is working within the microgrid, together with additional generators such as solar panels. If we look at the whole picture, that allows us to reduce cost. Cost reduction, first of all, comes from planning. If you do good planning, looking at what the expected or what's the available utility tariffs that you have for that site, you select one that has demand cost. You make sure then that you never get over that demand at all times, or else you're going to pay heavily. In many places, especially in Europe, but we see it more and more in the US as well, it takes a long time to upgrade the infrastructure. And that ability to do smart energy management allow you to postpone, to reduce this investment in the CapEx or avoid it altogether. Of course, it increased resiliency. If the network is not stable, you don't have enough power, or this site doesn't have the power that it needs, adding the additional inputs such as batteries and PVs into this mix allow you to charge more even if you don't have enough from the grid. A very common request that we see across the grid, of course, is how do I support the regulations, the ESG goals, etc. of the company, allow my infrastructure to become greener while earning additional revenue. And that can be by joining, as Arian described before, a program such as a demand response program or a flexibility program by offering the assets on your site to this market. So what does this whole solution offers in general? First of all, of course, is making sure that your breaker will not trip. If you have spikes, unmanaged load together with charging in parallel, your breaker will trip, and by shifting the energy into other times, by making sure you take energy from the battery when needed and charge the battery when you can manage this risk. The system is smart and allow you real-time decision so that at any point in under a second response, you can receive meter reading and make sure that you act according to this change. One of the most common things that we hear from all customers, especially new ones, is that I didn't take into account the unmanaged load. So I did count how many vehicles I'm going to have, but there is also another consumer on that site that I don't manage. Taking that into account, receiving the meter reading from that load and integrate that into the decision is a really important decision when you calculate how much energy you need. Allowing you to take additional energy from renewable, that can be a second phase when you're ready to grow and add a battery. Take into account different tariff plans, and that could be demand charge, it could be dynamic pricing such as time of use or other dynamic pricing that are available in the market, especially for high voltage sites, and by that reducing the cost when possible. Of course, a very important tool for that is a battery that can charge when energy is cheap and then discharge when energy is more expensive. There is an overall limit of the site. Make sure your overall power does not extend that limit and receive information from the demand response system of the DSO or the DCO. So when we look at the drive solution, we look at three different typical scenarios. It could be a combination of those, and I will explain. The one that we look at the left is the most common one that is used by most of our customers on almost all sites that has EV charging. This is a software-only, cloud-only solution that remotely receive meter readings from the chargers and send charging profile to the chargers from the cloud using OCPP. This works very well when the main consumer or the only consumer are chargers and you don't have an unmanaged or unpredicted load in addition in that site. We can still handle unmanaged load, assuming it's fairly predictable in this scenario. When we go into a more complex scenario, we offer also a combination of a local controller. Drives offer our own local controller. This is the Spark Core controller that is connected directly through Modbus to a battery if it's available, and can communicate directly through API to the Drive's cloud. All the profiles are still sent through OCPP in this case. In case the chargers also offer a Modbus communication, and that would be the right option, we can decide how we actually control the chargers. That could be done still through OCPP, or energy profiles can be directly sent through Modbus to the chargers. And this topology allows a very, very quick response. So if we have an unmanaged load or a combination of multiple assets, such as PVs, meters, a building, a battery, etc., we would go with option number 3. I would say that in this point today, this is still the most the least common scenario, and of course the most complex to handle. We see it grow more and more, especially on high voltage sites that has multi-megawatt of energy.
Okay,
Rami?
so yeah,
sorry.
my turn.
Okay, super.
You want to stop for questions or continue after? Or question
So
after?
yeah, we do have some questions from the audience that maybe you can take, Oren. The last one that just came in, someone's asking how frequent is the OCPP communication with the charge point management system?
It depends on the need. A very common one will be 1 per minute, but we also see integration of 1 per second meter reading. We support all of it. It has the cost of the actual data, but if it requires, and it's the we see a lot of variation in the demand in the charge in the site itself. We can move into 1 per second.
Okay, and there's another question. It's just popped away from my. There it is. Maybe a bit more of a maybe philosophical or holistic question. Someone's asking. John's asking, what's the best baseline mix of the different assets for a single site, meaning solar, battery, EV charging, and the grid connection? Is there some kind of optimal mix of these?
I think there isn't one answer that fits all. It really depends on the use case, the business use case, how fast the vehicles needs to leave, how much time do they have to charge their, how much panel room do you have for solar. There is a cost for battery, and we have calculators that allows us to understand what is the ROI for the whole site. So what we usually do, we put all the business requirement into this calculator and come up with number of chargers, speed, battery size, number of solar panels, and etc. And this is a service that we can offer if someone is starting up and still doesn't have the experience.
Okay, and maybe we'll take just one more question before we hand over to Yossi. Nasreen is asking, what is the primary function of the local controller? And can we achieve a similar level of control with option 2 and 3 using a cloud-only solution?
Sure. The functionality is very, very similar or almost the same. The main difference will be the ability to connect through a Modbus to the chargers, the battery, the meters, etc., and the ability to respond with under a second, which is very challenging to do when you have the cloud communication back and forth. As I said, most cases, the option number 1 is good enough.
Okay, so I think this is going to be a good time to hand over to Yossi, and if we do have time at the end of Yossi's session, then we'll try and take some more questions from the audience. Yossi, let me bring you on screen. And Oren, wave goodbye for now. Thank you very much. And Yossi, take it away.
All right. Okay. So hi, everyone. It's great to be here. So building up on what Ariane and Oren just explained, you can see that we are in the middle of really 2 revolutions here with energy and EVs. And basically, EVs just introduce more energy challenges, as we all know. And so basically what we're doing at Drives is to make sure that we provide the solutions to facilitate all this and to allow you as CPOs to also monetize on it. So it's not just about keeping the lights on, it's also about offering additional services and additional revenue streams and solutions to your customers, to the end drivers or to fleets and all the ecosystem. So I'm going to be covering a few concepts, and I'll jump to the next slide with Smart Chain for that. So we'll talk about load balancing, we'll talk about prioritization, cost optimization, and time-based charging. Okay. So really, when we look at the solution that we call this Smart Chain, it's been around, I don't know, maybe Ariane remembers the exact date, for the past 8 or so years. And basically, this allows you to handle very large topologies of campuses and sub-parking lots and all sorts of additional equipment, such as the meters that Oren and the non-managed load that Oren was mentioning. But it also deals with the other aspect that I was mentioning. So first of all, load balancing, and it's basically looking at the group of chargers, making sure that they all continue to charge, making sure that the load is balanced properly, and when another vehicle connects, the other respond accordingly to make sure we don't have any outages, any power outages. But then you can also introduce priorities so that you can offer higher priority business plans or plans to your drivers. And basically, these assure that they charge faster, or if a certain vehicle needs energy sooner because it has more tasks in a case of a fleet, then we can make sure that that is allocated to them and that they can leave in due time. But this is also completely dynamic, meaning it can consider prices that are coming in from the utility, and then when prices rise, it can automatically reduce the rate of charging, and when prices decrease, it can increase rate of charging, and it plans for that. It is able to look at day ahead prices or live, and I'll show that in a second, and then it can adapt to that. Furthermore, it uses the storage. So when prices are low, it can basically charge from the grid, but when prices are high, it can use the battery, as you can see here also on the screen. So there's a lot of different aspects to optimizing cost, prioritizing between individual drivers and tasks, and also, making sure, as Oren mentioned, not to go over the peaks or anything. So if we continue to additional aspects of the mine-site flexibility, I'd want to talk about, again, the concept of cost optimization with additional inputs and how to integrate with OpenADR. I am very happy that, as you heard from Arjan, the OCA or ILAD in the Netherlands are actually adopting OpenADR. That originally stems from the US, but we're already starting to see it worldwide. And we'll also talk about V2G, basically, and how we can actually use the vehicles as portable batteries, and what's the opportunity there. So basically, when we're talking about behind the meter, we have the ability to tap into day-ahead market signals and basically allow drivers specifically to tap into this and to save money and to basically tell us their needs and to avoid the peaks when energy is much more expensive. And so basically we can utilize, if it's a site with PVs, or even if it's a home charging scenario, that can be managed. So if we look at that, we integrate with sources such as Nord Pool, and we get the signals. And on the right here, you can see a very simple illustration on how you would start charging. And once you start charging, you can actually go in and select your charging parameters and say, okay, I'm going to depart at a certain time. Why did this stop? Did the video stop? Are you seeing the video, Rami?
Yes.
Okay, here it is. So it'll pop up the when you can set your time of departure and your target battery level, and then this will allow the system to further optimize your charge and make sure you don't pay as much. And basically, if you need max power, you can say, okay, I want max power because I want to leave as soon as possible, etc. So these tools basically help drivers tell us what they need and basically can save them a lot of money at the end of the month. Okay, another aspect is OpenADR. OpenADR is used to get signals from the utilities. I saw some questions about this before. And we basically, with Smart Chain, we integrate all this information and take smart decisions based on all these signals. So OpenADR stands for Automated Device Response. The concept there is that there is a virtual top node, which is for simplification, that's the DSO. And that top node talks to all sorts of end nodes. In our example, it's us. It's basically drives as a CPMS, as a CPO, and it gives us signals on what's going on, price increase, congestions, all sorts of things which we need to consider. And then basically we take these signals and translate them into charging plans and profiles. But we're not just using what's coming from the utility, we're also considering everything, like what does the driver need, what is his billing plan, maybe he needs to get higher priority, what's the actual state of charge, what are the grid constraints and the local grid constraints with all the wires and everything. So this kind of takes a broader look at what needs to be done. And then basically this controls the load that the DSO needs to cope with. So that's the motivation behind OpenADR, and that is to affect the end customers, the end consumers, in order to change consumption at the DSO level. And of course, this allows us to utilize the more advanced devices such as batteries and PVs. And when we consider those, we can reduce the load on the grid and still fulfill what the drivers need faster. So just to kind of look to see how this looks, this is a kind of a charging graph where it shows where OpenADR events can come in, where the arrows are, and just tell the system now you should drop consumption substantially because we have a congestion situation, or we increase prices over a threshold and we understand that it's not the right time to charge. So we reduce that. And then later on, once the other event comes in saying, okay, we're good to go now, then we can start increasing this gradually. And of course, it depends on how much energy the vehicles still need and other available energy, of course. So if we look at Smart Chain again, that is completely integrated. It's actually completely transparent. You don't really need to know what's going on as an operator. You just make the connection and you let it work. That's what everybody wants, right? Everybody wants it to just work. You don't really want to bother with it. You set your policies, you set prioritization, high-level parameters, and the system does the rest, as you can see here. So the kind of the last topic is the promise of V2G. So as Aryan showed you those wonderful red charts, I remember the ones from very early days in 2015, 2016, 2017. They weren't as red at all. So as you can see, we're headed towards quite a big challenge everywhere. And so what we believe the solution. The EVs are not the problem, they are the solution. And because we can actually use them as batteries on wheels, and hopefully once the resilience of the batteries improve and the business models improve, then we'll be able to extract power more easily from the vehicles, put it back into whoever needs it, and then alleviate the load on the grids even further. That just completely augments the solution landscape, where we can actually use each and every vehicle, because as you guys know, there are many, many vehicles. Yeah. So just kind of to recap, thank you all for joining and sticking around. We covered the grid constraints that we have and how does a typical site look with all the different loads and all the different constraints and signals that can come in, and basically we need to consider. And we covered our smart energy management solution, which basically taps into all these sources and is able to make smart decisions to not only keep the lights on, but also enable you to make more money and keep customers much more happy and be able to be on their way as soon as possible. And of course, there's a lot of opportunity in there, we think, and we hope that you will start incorporating these solutions more and more. As Rami started with, we do see a very, very steep increase in the market. We've been waiting for it for a long time, so it's really nice to see it happening. Thank you.
Well, that's just perfect timing, and it gives me about 30 seconds to thank you all. I'm going to bring you all back on screen. I do want to thank all our speakers for joining us today, and all our audience, of course, for taking the time out to hear you speak. A special thanks goes to Yossi for coming out of your sick bed and talking to us, even with a fever. If this is how you talk with a fever, I'm happy to see how you talk without a fever. Unfortunately, since we're at time, we won't have time for any more questions, though I see many have been answered in the chat window. Thanks again, everyone, for joining us, and we look forward to seeing you again in our next webinar. Keep your eyes and ears open. Bye-bye.
Bye-bye,
Thanks.
everyone.
Bye-bye.
Thank you.